In this lecture, we will be discussing a new library named Pandas and Dataframe, which is a new data structure. From now on, we say goodbye to our first textbook and focus on the second textbook, Python for data analysis. And Pandas Library is in chapter 5 of our second textbook. Pandas is a popular Python package for data science. We use it for data manipulation and analysis, especially for numerical tables and time series. Pandas offer powerful, expressive, and flexible data structure that makes complex data manipulation and analysis easy. Here are a few examples. It offers powerful functions to handle missing data. You can also use its function to efficiently group objects and do a statistical evaluation of each group. Dataframe is the main data structure when we are working with this library. In this slide, you can see a table with 4 columns and 3 rows. We can use both list and dictionary to organize the data, and you see both of them here. On the left side, the dictionary, and on the right side is the list. So under dictionary, you can see that each row is saved in a dictionary and the variable is a list. So you have a list which has several dictionaries, and each dictionary represents one row in this table. And for list, you see 2 variables, sales, which is a list, and all records are listed or saved in that list. And also you have another variable named labels, which represent the column's name or headers. To create Pandas data frames from list and dictionary, you can see that we need to import Pandas library, we call it, and then the method is named Dataframe. So if you have this example, a list with several dictionaries, then pandas.dataframe, as you can see on the left side, then you pass on sales to this function and you create your data frame, which looks like this table. If you are using the list, then you call pandas.dataframe and use another method named from underline record. And then you pass on 2 arguments. One is the list, which is each row in this table, and then columns equal labels, then present the columns headers. And this is how you save data row by row. And if you want to save it column by column, then you have the example here. Okay. Now let's try to start from scratch, create a data frame which has 3 columns, and the first column is time, the second is X, and the third column is Y. So let's go over the code, the piece of code you are seeing in this slide, and then we try to implement it in a notebook. We are importing 3 libraries. Import random, that we have worked with this before. Import math, because we are going to use some of its function. And then import pandas as PD. So this is the new library we are working because we want to create the data frame. And as you can see here, I'm assigning a nickname PD, which is shorter. So each time that I want to call pandas, I just type in PD. Okay. So now we need to create 3 variables first, time, X, and Y. So the first one, I define T as a list, an empty list, and then I write a for loop. For L in range 10, so we want to repeat this 10 times. I'm generating a random number between 1 and 6. And then I use the append method to populate that list. So t.append number. So at the end, we will have a list with 10 items, and they are all randomly generated between 1 and 6. Okay. For the second variable X, the data structure is a list, and you see another for loop, this time for L in range length of T. So here we generated a list, and len of t returns the number of items in that list. So here, if it is 10 items, then we will repeat this procedure 10 times. Now number equal to, I'm importing or using the math module dot cosine, which is a function defined under this module. Now I want to go through all items in that list and calculate its cosine. So math.cosine t, so it's a list. In order to get access to each item, we need to specify the index. The first index is 0, 1, all the way through 9. And then I populate this list using the append method, x.append. So for t, I generate random numbers, and for x, I calculate the cosine of those random numbers. And for y, I want to calculate their sign. So y is another empty list, and we write a for loop if we want to go through all items in that list. And then math.sign is a function defined under math, and t bracket L. So it means that go through all items in the list and calculate its sign, and then add it to y variable using append method. So far we created 3 variables, and their data structure is a list. And now we can put them together and present it in tabular format. So I define another variable, df, equal, we call panda or pd.dataframe. So for Dataframe, then we need to specify how many columns we have, what the name of each column, and the value. So Dataframe, then you'll see curly braces. The first column header is time, and then its value is t. The second column is x, and its value is x. So we use colon to assign value, and the same for the third column. So now let's try to implement this and see what this data frame look like. First, we import the libraries, random, import math module, and the new library pandas as PD. Then we define our first variable, which is a list. We want to generate 10 items. So for L in range 10, colon, generate a random number and assign it to the variable name number. So random dot randint, that we worked with this function before, generates random integer numbers between, let's say, 1 and 6. And then we want to add this to the list that we just defined, t. So t.append number. Let's run this. And then for x, we want to calculate the cosine of the random numbers. So another empty list, and then a for loop, because we want to go through all items in the list. So we use the range function, and len of t returns the number of items in variable t. And here I define another variable. So in the first iteration, it goes to the first item and then apply as this function to that item. And in the second iteration, goes to the second item, then calculates the cosine. And now we want to save it in variable x. So x.append number. We can also print them. So print t. So 10 random numbers between 1 and 6. And let's print x, which is the cosine of these numbers. And you can see there are 10 items because we calculate cosine for each. And we have another variable, y. We use the range function, len of t. And this time we calculate the sign. Number equal to math dot sign for each item in variable t. And then we save the result in y. Let's run this, and then we can print this variable, and each represents sign of the numbers here. Now we can define our data frame. First, we call Pandas Library, PD, then Dataframe, curly braces. The first column header is time. We use colon to assign value, which is t, then comma. The second column is x, and its value is variable x. And the last column is y. Its value is y. Let's run this, and then when we print, so you can see a table with 3 columns and 10 rows. And you can see that for each row there is an index. By default, the first row is assigned to 0, second row 1. So we have 10 observations here, or 10 records, 0 through 9. So 1 index is assigned to each row. And as you can see, it looks like a table. So we generated or created our first data frame using lists. Now let's see how we can get access to different rows and columns. In Pandas, rows are addressed through indices and columns through their name. For example, we just want to work with one of the columns, or if columns represent different features or variables in the data set, and we want to work with one of them. So we call the data frame, the variable we just created, dot the column that we want to work with. And here you can see 2 examples, df.time or df bracket, and then you call the name of that column. Either way is fine, and you get the same result. And if you want to extract 2 columns at the same time, again, we define another variable called data. We call the original data frame, and then the name of 2 columns that we want to work with. Here, for example, time and y. Now, if we want to extract 6 rows, so let's say we want to just focus on some of the rows or records in the data. So if you want to extract 6 rows starting from 5 to 10, then you call the variable data for column 10. Remember, the first row is assigned to 0. So if you want to see rows starting from 5, then you look at 4 through 10, because the first row is automatically assigned to 0. And numbered rows and labeled columns can be addressed simultaneously. So you want to work with a specific columns and a few records. So df, time, and y in this example, and just observations starting from 5 through 10. Now let's run them in a Python notebook. if we just want to work with one column, in this example, time, oops, we don't need the, okay. So you can see the values under time along with their row number. The other format is df.time. So there are two different ways to work with a specific column. And if you want to extract two columns from the original data, we define another data. So df is square bracket. Let's say we want to focus on time and y columns. And now if we can see that you created another data frame with the same number of rows but just two columns. And if we want to extract 6 rows from 5 to 10, then we call the data frame here data 4 through 10. If you run it, you can see data is referring to this table, and from row 4 through 10, the same values here. So if you want to work with a subset of data, that's how you can define which rows and which columns you want to work with. Now let's say if you want to work with numbered rows and labeled columns at the same time. So we call let's say the original data df time and x columns, and then you specify which rows, let's say 4 through 10. Now you can see you have the table with 2 columns, time and x, and only observation from 4 to 9. So here's a practice. So let's create a data frame which has 10 columns and 4 rows with random numbers in each row. So there are different ways to populate a data frame. Before we used a list, and then we combine them in a data frame, or you can use dictionaries. So at this point, I encourage you to pause the video and try to create this data frame, and then compare your code with mine. For this practice, so I'm going to define a list for each row. So we want to have 4 rows, so I define 4 empty variables, which are lists. Again, this is just one possible way. You may prefer to use dictionaries. So so 4 empty lists for each row. And then I define a for loop in range 10, because I want 10 columns for the data frame. And then I generate a number, so random number equal to, again using the randint function, between 1 and 6. Now I want to populate this empty list. So a.append, then add number to the end of this list. Multiply the number by 0.12. I'm just generating different random numbers. You can have different strategies. And then c.append, the generated random number times 12. And these are just arbitrary. You can change the coefficients. Append number times 56. If we run this and let's print A, so it has 10 items, random numbers between 1 through 6, and if we print B, then it should be each 2 times 0.12, then you see the result. So far we generated 4 lists. Okay. Now I define another list named data and assign all lists to, or combine them. So technically I'm generating a list of lists. A, B, C, and D. So let me print this variable data. So its data structure is a list. So we see a square bracket and there are 4 items and each item is a list itself. So A, the second item, is the list saved in variable B, and so on. So now I combine all generated numbers in one list. Now I can create a data frame and name it df. And again, this name is arbitrary. You can go with, let's say, test. We call Pandas Library data frame. Now we assign this data to the data frame. Data, and the second argument is columns, the name of each column, which is equal to another list. Let's say I go with A, B, so we need 10 columns. Through J. So we need 10 names for 10 columns, and the data is saved in the variable named data. Okay, let's run this. And now if we print test, you can see that we have a data frame with 4 rows and 10 columns. The first row is the random numbers between 1 and 6. The second row is random numbers time 0.12, and so on. So in the previous example, when we wanted to define the data frame, as you can see here, I used a dictionary. So the column header is the key, and then we assign value. And there is, in this example, you saw another strategy, that first I assign the data, and then using columns, I define the headers for columns in our data frame. So either way works. We also learned importing data from text files. So we can load a text file and save that in a data frame. So before we practiced for dictionaries. So we read from text file and then save them in a list or dictionary. Now here we want to load a text file and then create a data frame. The text file is salary.txt, and I have uploaded this file to Canvas. Let's open this text file and see what it looks like. Okay. So you can see that in this text file, there are 1, 2, 3, 4 columns. The first one represents employees. The second one is their salary in $1,000. The third one represents years with the company, and the last column is their gender. Okay. So now we want to read from this text file and then create our data frame. So you see the code here. There are 4 columns, so I define 4 empty lists. Then I open this text file. We are in reading mode, and then we go through all lines in that text file. First, we split the items in each line. So line.split by a space. So it goes through the first line and then split the words by a space. So the first one is the employee names, and then a space, then it's split. The second item becomes their salary, and then split the other words. So technically there will be 4 items in each line, and that's why we apply a split by a space. So item 0, the first one, we assign it to X, which represents employee's name. Item 1 is the second column, and we assign it to Y variable, which is their salary. Item 2, so the position is 2, or the third column, then we assign it to Z, which represents years with the company. And the last item, its index is 3, and we assign it to W, which represents the gender. And then we use Pandas Library, Dataframe, and a dictionary to assign values to each column, and you can see the header of each column here. Okay, let's try to implement this. First, we need to upload the text file. Here, you go to the home page, you can see the upload button, right top, and then you upload it. I have already uploaded that file. Then you can see salary.txt. If you click on it, then you can see the text file. So the first item, then you see a space. The second column, then you can see a space, and that's why we applied a split method by a space. So each one is assigned to different variables. With that, let's try to implement this. X is an empty list representing employee's name, Y for their salary, Z for years with the company, and W for the gender. First, we need to open the file. The file name is salary.txt, and then we are in reading mode. When we open it, then we can go through lines. So we write a for loop for line in this file, colon. First, split each row by a space. So I define a variable items equal to line dot split, and split by a space here. And then that items has the items variable technically has 4 elements. So we assign the first element to X using the append method, and its position is items 0. Because each item in a list is assigned an index. The second item position is 1. And then Z dot append items 2. Then the last one, append items 3. Let's run this. And now we can call the pandas module. I define another variable named df. So pd.dataframe. I am using a dictionary to define columns and their values. The first column is employee, the value is X. The second column is salary, its value is Y. Third column is years, its value is Z. The last column, let's say 6, and the value is W. Let's run this, and if we print, now you can see that we have a table, a data frame with 4 columns, appropriate headers, and 25 rows. The first one is assigned to 0, 1, 2, all through 25, through 24. Okay. So that's how we read data from a text file, and then we save it in a data frame. Now I would like to go over a few useful methods. So when we create data frames, then we can manipulate data, right? We can get access to some columns, we can drop a column, or we can re-index each row. So for large, let's start with the first method here. For large data frames, the head method selects only the first 5 rows. So when you call your data frame .head, and then you can see the columns, their headers, and the first 5 rows. So for example here, if we apply the head method to this data frame, so df.head, and then you can see the first 5 rows or observation. Sometimes you don't want to print the whole data, you just want to see a few rows to make sure how the data frame is created, or it is what you expected. The other method is delete, or del. This method can be used to remove columns. For example, we want to remove the last column, 6. So del df bracket and the name of the column that you want to delete. Okay. So del is a reserved word, so the color is green. Okay, delete df this column. Now let's print, and you can see that your data frame has 3 columns, and we remove the last column with the same number of rows. And as you can see, when we create a data frame, an index is assigned to each row. By default, the first one is 0, the second row is 1, and then depending on the number of observation in data set, it goes on. Now, we can use index to assign different identifiers to each row. Let's say I define a variable list, and I use the range function, which starts from 3 through 29, and the step value is 1. So technically, I want my first observation to be assigned to 3, the first row. So to do that, we call pandas data frame, and then the second argument is index. So index equal to the list variable. So let's run this, and you can see what it looks like. So first I define a new list, which is a range function starting from 3 to 29. The step value is 1. Need parentheses here. Now let's print this. So it is a list starting from 3, 4, through 28. Now I want to apply this index to my data set. So df Pandas Library Dataframe so the dictionary employee, its value is X. The second column salary, its value is Y. Third column years, its value is Z. The last column 6 and its value is W. And then comma, you can pass on the other argument, index equal to int, which is a list we just defined. Okay, we get this error. So when we see this error, it says shape of past value is 25, 4, and indices imply 26. So it means that the new index we are trying to pass on doesn't match the number of observations we have. Okay, so here we have 25 observations. Probably we need to change it to 28. Okay, now let's run this again. Okay, so we fix it. Now let's print this. Okay. Now you can see that this data frame has 4 columns, but the first row, its index starts from 3. So 3, 4, 5 through 27. So technically, we change the index and we apply the new index we defined. If you want to pass on a string, then you can define the list of strings, and using the index method, you define this identifier which is assigned to each row. We can also apply the reindex method. Reindex rearranges the data according to the new index. Let's say we want to define another index named index 2, and then we apply the reindex. So let's see what happens. It just rearranges the rows in your data frame. So I define another list, index 2. Now I'm using this index, and let's say I want to see 20th observation first. So I'm changing the order here. And then the rest of observation. Now let's see what happens. So I define another variable named df2. So I call the original data frame df, apply reindex method based on the defined list, index 2. Now let's print this. And you can see that the first row starts from the 21st, 20, 21st, 22, and then from 3 to 4. So if you compare the row 20, the employee's name is Roberts. You can see it's the same observation. It just rearranges the rows in your data frame. There is also another method, drop. The drop method returns a new data with the indicated values deleted from the original data. So when you want to drop a column, we use delete method. But if you want to drop a row, a specific observation, we use the drop method. Let's say we want to drop row with index 17. So I define another variable, Dataframe3, the original Dataframe.drop. Now I want to drop row 17s. Let's see what happened. df3, we print it. So you can see it start from 3, 4, 5, and then 16. We drop 17th and then 18th. So that's how you drop observations or rows in your data frame. You can drop, for example, row 20th, then you can see that 19 and then it goes to 21. So in summary, in this lecture, we learned about Pandas, the new library in Python for data manipulation and analysis. Dataframe is a new data structure which helps with organizing data in tabular format. We can use lists and dictionaries to create data frame, combine them. We also discussed how we can read from text file to create data frame. And we went over a few methods like head, indexing, reindexing, dropping a row, or dropping a column. Next time, we will continue our discussion about data frame.